go on to Nick.
Thanks very much.
I wanted to.
Oh, sorry, go on, Jet. Ready?
Yeah, no. I wanted us to have a discussion at some point about our cloud strategy, but maybe that should wait until we've had some of the other talks that are coming up next.
Yeah, the first talk this afternoon is also on cloud, but it's a different angle on cloud. It's not cloud log analysis and log storage and management of that. It's cloud connectivity.
Exactly. Yeah.
So that's another piece of it. And they're both, important pieces of the puzzle. So yeah, I think we could have that as maybe after that talk.
Yeah, that sounds
good.
So
is Nick around? Nick, are you ready? He is. Look at that.
Very good.
Over to you, Nick. I can't hear Nick. Can anyone?
Can you hear me now?
Yes, that's
hear
better.
you. Yes.
Yes, can indeed.
All right. Finally got it figured out here. Hi, I'm Nick. This is the Autopilot ESP32 port status update. I just
Nick's first presentation.
Yeah, in a long time. I just want to give a short update on the ESP32 port, maybe drum up some more involvement. The last 12 months have been exciting for this project. It's been a long time coming. The first commits I've seen were May 2019. Alex, Buzz, and Charles all shared their work among other people. Several of us took interest, have been testing. It was finally merged into master in November 2021. There are various modules that have been tested at various levels. All of them at booting, which is not surprising since most of them use very similar modules. The main difference between them is storage space and the pinouts. They're readily available for many sources. You can see the specs there. I think for experimental hardware designs, I think everyone has started with a breadboard, maybe went to perf board. Some have had custom boards made. Buzz's design was made a couple years ago. Charles is working towards his PhD. Dimitri, a relatively new user, he's making a sailboat. I have seen designs from UK Nuke and Flea Time. Myself, I'm focusing on single board design, so I'm able to make it home with my daughter. I just really use this entire project as a way to be able to do projects. Upper left is a design I did for an AP at Perif node. In the middle up there, that's Dimitri's board for his sailboat. Right hand side is another single-sided board design I've done. Down at the bottom, you got Buzz and Charles in the middle. And on the right is a shield for a small copter we'll talk about in a minute. As for testing on vehicles, Buzz has a plane. Charles has been testing rover, copter, and sub. I have a plane, couple copters I'm messing with. Made a RC car. Again, Dimitri's doing sailboat. I wouldn't run on a $1,000 drone yet, but making a phone plane or retrofitting an RC car is a fun weekend project with the kids. Here in the pictures, it's showing Dimitri's test rig. He's got his boat ready. He's getting ready to install. Buzz shared a picture of his Bixler. At the bottom, the couple quadcopters I've been messing with. Recently, I added a PR to add support for this ESP32 IMU module. I found this on Tindy. It's an open development platform for an ESP32 microcopter. It's all open source, available on GitHub. They have the board design schematics, everything. You can download, edit it, make your own. I have a small demo I want to do here. So here's the mission planner connected to one of the ESP32 IMU modules. I'm just powering it with this power bank here. I do have a Barrow connected. I don't have the GPS configured at this time. You can see that it's showing the internal error. There are just various bugs that need to be worked out. You can see the graph from the IMU at the bottom showing it as real data coming in. As I said earlier, there are a few different versions of the prototype hardware. Buzz has some code booting AP-perf. Recently, we've added the SD card logging fix and GPS detection. There's not in master yet, but some fixes have been identified. Charles has been working on WAF improvements, allow for a dynamic list of boards for easier integration of new designs. We also have the ESP32 S3, that's the new ESP32, booting and running on a few benches. Buzz also moved us up to supporting IDF 4.4. We're slowly getting more interested participants. I really like to see more participation. What's the future outlook? Well, we really need to improve our documentation, need more testing, bug identification. Someone could fit more hours in the day, that might help. Getting AP-perf running stably might be interesting. Dimitri's been doing a lot of testing, finding, and offering solutions to issues. Buzz has incoming changes to support the IDF 4.4 and Charles's WAF improvements. I'd like to focus on documentation, integrating with the custom build server and argue configurator, as well as a hardware test rig for continuous integration. Primary discussion is on Discord in the ESP32 channel. You can find the README in the AP HAL ESP32 library and master. Hopefully I sparked some interest today. Is there anything you'd like to add, Buzz?
Just maybe that the new, the S3 variant that's just sort of come online recently, it's actually faster and sexier than the old one. The old one was a LX6 microcontroller. The new one is an LX7 microcontroller, and again, it's dual core like the old one. And it's got Wi-Fi and Bluetooth 5 built into it. So that particular one has got more GPIO as well. So I think the S3 variant is sort of going to be the future of this. But for smaller nodes and smaller quads, the old ESP32 is great. That's all.
Thank you very much for that. I'm really glad you were able to give the presentation, Nick. So as you noted about the custom build server. So that should be very easy because now we use that board list. So it should just be a matter of updating the board list to add up a white list of the ESP32 targets. And
I have a little bit of testing. I was getting an error with the actual build itself. Like I got
well, we need to do the submodule. ESP32 relies on some code that isn't actually in submodules. So we'd need to fix that to get it to update that code, apply that patch. And we'd also need to install the various build tools to make sure that all the right compiler and things have been installed on the build server. But I think it might be like half a day's work or something, but it shouldn't be too terrible to get the custom build server to support it. And particularly once we have stable branches and things that will, in the build server, I think around that same sort of time, we should add ESP32 builds to that.
Yep. Like I say, I have a local instance that I mess with, and I just really enjoy all the different parts of the ArduPilot organization and have a good time.
Yeah, definitely. It's really
Yeehaw!
cool. And the ESP is really one of the most important. A very popular board, right? I mean, they're used in all kinds of different projects, so people are pretty familiar with them. So it seems like a great board to go with. I really
It's
actually
the
gotta say,
cheapest.
yeah. Go ahead. Sorry.
Sorry, I was going to say it's the cheapest Wi-Fi stack you can get, basically. And it comes, if anyone can see my video, it comes looking on this is the latest one. This is the S3 variant. But there's a couple of other variants. And the whole thing's available for around $20.
How does sorry, I know Tom's trying to ask a question, but I'm just going to jump in one more. How powerful is the ESP32 compared to our other flight controller? You said it's dual core and
dual core 240 megahertz. So it's more powerful than a Q Black, for example, but it's probably a little bit weaker in some areas than an F7 or an H7. But it is dual core, and one of those cores is pretty much dedicated to Wi-Fi right now, but we could use the other core for things. So if you think of it sort of slightly better than a Q Black, but not as good as a Cube Orange, you're about in the ballpark.
It's got that built-in Wi-Fi, I think, which is Wi-Fi and Bluetooth, like you said, which makes it really convenient.
And this,
really package.
It doesn't need any additional telemetry radio. This is got the antenna right there, ready to go. It's fully telemetry enabled right out of the box.
All right, so I have two questions. I guess an easy one and a hard one. The easy one is there's lots of talk about issues with AP perf. I was wondering if you guys could talk more about like what the problems you're having with that. And the second one is, okay, you have Wi-Fi. Now what? Like how do you configure it and all that?
I'm the only one who's really done anything with AP perf, and all I've done at this point is sort of connect one of these devices which has a built-in CAN controller. We wired in a CAN chip that allowed us to talk over CAN, and I got AP perf just barely to the point where it would boot. So we're not at the point where AP perf works. We're just at the point where we've kind of proven it can. It needs a lot more care on the code because my CAN code is terrible. I'll be honest, it drops packets left, right, and center, but it does actually show up on a CAN bus, and you can actually ask it to give you parameters and a few other things like that. So it gets a CAN node. That's about as good as we get.
So the limitation is more about the hardware abstraction layer of the ESP32 handling CAN traffic.
Yes. So because we're not using Chibios, we're using FreeRTOS. The whole HAL is brand new. It doesn't get to sit on top of all of the work that Tridge and Sid and others have put into the Chibios HAL. So it uses FreeRTOS, and because of that, it has to have its own CAN drivers and its own Wi-Fi drivers and its own serial drivers, and all those sorts of drivers are all different. So as far as what's next, well, once you boot one of these and turn it on, if you've got an IMU connected to it, which this one does, here's a little cheap $10 IMU. Once you power that on and you've got it flashed, you can just connect to it over TCP/IP with the Mission Planner. You don't need any other telemetry hardware. Or you can use UDP if you want. It supports either.
So it just pushes a single stream on one port kind of thing?
That's right. Yep. You just connect to it on the usual TCP port of 5760 or the UDP port of 14550, I think is the default port. Mission Planner's default ports is what we used. So it just connects. And that's pretty much all there is. It's pretty simple to use. It's just the HAL layer. It takes longer for us to get at places because we have to write the drivers.
Sure. Now the Ethernet stack or the IP stack is actually hard coded into there, right? That's their proprietary thing that they have.
It's not entirely proprietary. It's supplied by Espressif, who make the hardware, and it's actually what they call the ESP IDF, and you can actually go on to GitHub and you can see ESPRESSIF and the IDF. It's all in GitHub. So it's only proprietary in that it's someone else's code, but it is based around open source code. It is available, and it's sort of outside of our repo rather than in it.
Oh, I always thought that the ESPs had some sort of like fixed binary, or precompiled binary that had API calls and stuff.
So not really. It's
okay.
got the TCP/IP stack is part of that.
Okay.
Any other questions? No.
This will be a nice target too, because we're planning on expanding just IP support in general. The plan for that would be, because there's so many different configurations, we'll plan to do it over scripting. So do you have plans to support scripts and either SD cards or anything like that?
Yes, this particular one actually has SD card support. I don't have it populated on the board right now, but we can actually connect to an SD card. This board doesn't have it, but my Bixler does over there. But yeah, SD card fully works. In fact, depending on how you physically wire it, we can do MMC mode or SPI mode for the SD card. They're both actually drivers that have been written.
Okay, cool. Well, I guess heads up. Make sure you can do on your RTOS make sure you can do the embedded files for scripting and such.
So I believe Charles spent a little bit of time compiling it with scripting enabled. I personally haven't run a Lua script on the ESP32, but I have certainly run AP-perf. So we have sort of a few targets that work, or can work.
I've been working with Sid a bit on some scripting IP stack stuff, and so we're going to come out with like kind of her portfolio, a whole portfolio of like IP enabling features soon. So that'd be a good platform to kind of test with, or to help deploy with as well.
Yeah, I think ESP32 would be very interesting for also creating like antenna tracker, a beacon for ship landing, those types of things. Where basically they the Wi-Fi being integrated nicely. I mean, it'd make a lovely beacon. Just running the rover code combination with 2 GPSs attached for GPS yaw. And I think that would be very nice, very low cost, small, easy connectivity with the Wi-Fi. I think it could be quite attractive. And similarly, you could integrate it very nicely as an antenna tracker. So I don't think we should think about it just for flying vehicles. I think it's got a lot of uses for, other use cases.
But it has been used on copter, plane, and sub at this point.
Mm-hmm. Fantastic. So we've got to get antenna tracker in there.
Yeah, it's great to see use on all those different vehicle types. That's pretty impressive.
Yep.
And I also totally agree with what Nick was saying about adding documentation to help help with uptake. I think once you sort of make the path clear, once the first few developers and then pro users, beta testers, clear the path, and then you document it, and then the next wave coming through, doesn't have to work so hard. They can just kind of buy the hardware, stick it on their vehicle, yep, load up the code, everything kind of works as described, and you'll get good uptake. So yeah, well done.
So that's one of the things that we're missing right now, if I'm going to sort of say publicly, is that we're missing a off-the-shelf, ready-to-go board that has all of the things you usually expect from a flight controller. We have, pretty much everybody has at some point started with a dev board and a bunch of PCB hacks, and they've spun their own PCB, or there's not a lot of ready-to-go stuff. So it's right now that the README says, you need to use this particular pinout for this particular dev board, and you need to connect your SD card this way, and that's probably too hard for your average user who's not willing to solve stuff. But once we get a ready-to-go flight controller that's all plug and play, I think there'll be quite a lot more people willing to use it.
I think even if you have to do some soldering, some people will be okay with that, as long as you give them you can order a PCB from here and you have to solder these exact pins. As long as you make the documentation clear, then then
Yep.
and that'll,
I
some
think
people
it-
have to like work through the problem. Right, go ahead, Nick, sorry.
I think it'd be a great project for like hacker spaces, things like that, or even students learning basic, electronics and interested in autopilots or drones. And I think it could be a great learning project.
Yeah, for sure.
Cool.
Yeah, they're very small and light, the boards. Indoor planes would be an interesting one. Those little tiny fixed wing aircraft. And an
Like,
ESP32.
Paul Riseborough's tiny foamy plane that he had.
I was thinking the ones that people tend to fly indoor. Like we've got a monthly indoor flying thing at a local indoor basketball court here in Canberra. And they're tiny little planes running off 1S batteries. And you could actually do a bit of autonomous flight.
Dare I mention remote ID?
Yes, well, that's if you're going Wi-Fi. But as you know, remember talk from yesterday from Jeff. Wi-Fi is not necessarily the right choice. But
well, this particular
it does do Bluetooth though.
The ESP32 does Bluetooth as well. The older ESP32 does Bluetooth 4. The new one does Bluetooth 5. So we can sort of target one or both of those.
Okay. Well, that makes an interesting possibility. Yep.
Hey, Buzz. Josh here.
Yeah.
Discord question. I don't know what this is, but how is it possible to leverage ESP Now for native telemetry? I don't know what ESP Now is. So
ESP Now is a tech that Espressif sort of baked into their SDK to do sort of UDP-like comms. So it's like designed for less round trips than TCP/IP. But I think the ESP Now has a few things going for it in that it tends to hang on to the connection for longer and it degrades the link rates for you. And yeah, ESP Now as a comms link could actually be something that we might get value out of. I wouldn't be against people, doing that, but generally right now we have UDP and TCP working, and they're good enough for a telemetry link down to Mission Planner. So that is working and it's working well. You saw Nick sort of wave the drone in front of you before, and it was just connected over Wi-Fi to his laptop.
There was a user, HacksRL, that has released ESP Now RC communications along with telemetry, utilizing either ESP32 or an ESP32 along with an 8266, because they can talk between each other over ESP Now. I have messed with that project a little bit, but I think it would be a neat addition.
It's one of those protocols that I sort of logically compare to something like Crossfire or one of the other protocols that is sort of commonly supported by RC receivers and transmitters, in that it's another way of getting a link. So ESP Now has potential in just being another link that we could use, but it's not the one we'd want to probably default to.
One issue using ESP Now with MavLink directly is the allowable length of a packet is a little bit smaller than what the maximum length of a MavLink packet. So it would need to be packed in some way. Or
Cool. Any other questions? Anything else from Nick? Otherwise, I think we're just about done.
All right. Well, thank you very much, Nick, for that presentation. Really glad you got a chance to give that after the audio issues yesterday. And Nick's slides are up on the Discuss server. And remember, all the speakers, please put your slides up if you haven't done so already. Feel free to put them up before your talk. And